Okay, so this is problem number 2, and we're given the function. And just looking at they give me the graph, and what am I expecting to see? I'm expecting to see a root here. And in appearance, I'm expecting to see a root here. It appears to be a repeated root. Now, it could be deceptive, but it appears to be a repeated root there. We'll go through the work, though. What else am I expecting to see? A y-intercept. I'm also expecting to see a relative minimum, a point of inflection, and a relative maximum. So let me just write these down for you. I'm expecting to see a root here. I'm expecting to see a root here. Again, looking at it, it could be one root, it could be two roots. Look at it, pictures can be deceptive. I'm expecting a point of inflection over here. I'm expecting to get a relative minimum here. I'm expecting to get a y-intercept over here. And I'm expecting to get a relative maximum over here. All right? Now, it's nice to have a good picture, but a good picture could be deceptive, and you could blow that up there. It surely does look like a repeated root, but you know what? It could be deceptive. Maybe it just pokes through a little bit, all right? All right, they're very close together. That's what I mean by that. So let's take a look, and we're going to go to the whiteboard now. And the problem with going to the whiteboard is we just lost that picture, right? But this is typical. You don't have a picture anyway in most parts of life. You're constructing it. So I'm going to put down number 2. And number 2 is f of x equals, and it's x cubed plus 3x squared minus 9x minus 27. I'm going to try to factor that. It looks factorable to me. X squared, x plus 3, minus 9, x plus 3. I'm going to factor out x plus 3. I'm left off with x squared minus 9. This is x plus 3 squared x minus 3. So you know what? I get a rough idea what the picture looks like now. I know it's a cubic polynomial, and I get a rough idea. Y-intercept minus 27. I'll just put this down. This is rough. All right, what else do I know? I know I got an x-intercept at 3. We're not using the same scale in x and y, by the way. And a repeated root at minus 3. Right, I got a general idea what this looks like just by doing simple sign analysis on it. So what I mean by that is if I just looked at f, and the simple sign analysis, I'd have a point at minus 3 where it changes sign, and a point where it potentially changes sign, a point at 3. Now after 3, what do I get? A positive number. I want to point out this is always positive except where it's 0. So then I get negative here. I get negative over here. So I'm going to say something like this over here. And again, I'm not saying I exactly know what it looks like, but maybe something like this, and then something like this over here. All right, that's I would say a rough pre-calculus sketch without any calculus done yet. Now what I'm going to do, I'm going to refine the picture. I know my roots, by the way. They didn't ask beyond that, but I want to go beyond that. So what I want to do is get the first derivative. And what's that going to be? 3x squared plus 6x minus 9. I'm going to refine my picture with this. 3 comes out, x squared plus 2x minus 3. This can be factored further. I'm going to put the roots down of my derivative. I'm analyzing it. So it looks like at minus 3, and at, these are where the zeros occur, and at 1. After the 1, it's positive. Between minus 3 and 1, like if you pick 0, you get negative. Below the minus 3, if you look at minus 7 or something, it'll be positive. So what do I know? Relative maximum right there. But now I know the relative minimum is occurring about 1. I'll put it over here. Let me refine my curve, get my eraser out. I'm going to refine it. Again, it's a rough picture. This is my relative minimum. And where did that occur? At the number 1, f of 1. All right, let's do the second derivative, and we'll get our point of inflection. That's where the concavity changes. That will be 6x plus 6. It takes on a 0. Let me put this over here. At minus 1. To the right of minus 1, it's positive, which means it's concave up. To the left of minus 1, like it takes 0, it's negative, concave down. So at minus 1, I get a point of inflection. So the point of inflection occurs at minus 1, f of minus 1. And this is a point of inflection. Again, this is overkill. They just basically asked about the roots. If I were to respond what the roots were, roots are pretty simple. They're just simply going to be, if I wrote the list down, minus 3, and 3. There's 3 roots. It's from over here. We did more than that, though. Thank you.